We left off with this yesterday. This is still the molecular compound. Guys, I'm going to tell you this. It used to teach, we're going to finish this up today, and we're going to get into ionic. It used to take me about a day and a half to 2 days for students to understand ionic, but if you will commit to this, okay, and you will just listen and focus and pay attention, and you can do simple adding and subtracting, which you've been able to do your whole life, you'll know how to do ionic bonding before you walk out the door today. I assure you, you can do this, okay? So one of the first things that I want to talk about is just the differences in this. Now, if I did this in the right order, you were supposed to do the ionic one before you did the covalent one, but I personally like teaching covalent first because it's easier, and you get a basic understanding of the differences between ionic and covalent. So you know covalent. We've already done all those. And again, and I can show you this. Hopefully it's still there. I'm probably going to have to go back several pages because of AP today. I used a lot of pages. Right here. Okay. So remember at the very end yesterday, we wrote 5 rules. If you can do these 5 things, you can name any covalent compound. But it's just like I told you yesterday, the number one hardest part about this entire chapter is identification. You've either got to know if it's ionic or if it's covalent. That's the hardest aspect. But once you identify the fact that it's covalent, remember the first element only gets a prefix when. If the subscript is more than 1, what do you do to the end of the name of the element? Nothing. Leave it alone. Don't change it at all. Okay. When does the second element get a prefix? Always. Okay. And then what do you do to the ending on all second element names? Change it to IDE. And again, the prefixes, hopefully you have them memorized. 1 was, mono, 3 was, 5 was, 6, hexa, 7, 9. Good. You know all those. And remember, the 5th rule was the one that's kind of the funky one about the whole double vowel thing. If it's di or tri, keep the I. Very good. And hopefully those are kind of some things that you'll remember as we go through this. Okay. But today, I want to look at a little bit different aspect. I want to look at the ionic versus the molecular. So do me a favor. If you're on the iPad, you can do this. Draw a line between the 3rd and the 4th row. And we're going to differentiate here in just a second. Okay? So here's my question. These first 3, is there a similarity within these 3? Yes, what is the similarity? Very good. How many fluorines? They've all got 2 fluorines. Okay? So that's the similarity. But what's the differences? The first elements are all the difference, okay? Now, let's go over all the way to the end. What do you notice are the similarities in all of those names? Very good. Notice all of the endings are all "-ide", okay? But this is where we get into the differences. Now, if we look at the first 2, what are the types of compounds in the first 2? Ionic. Now, I'm going to bounce pages, but I promise I'll come back to this. Let me insert page before. Okay, so help me out because I can't see them anymore. What's the first one? MgF2. The second one is Cu, correct? And then the last one is SF2. Now, here's the way we're going to do this, and I'm going to teach you as we go. If we take these elements and we split it right there, okay? Mg. What is Mg? Magnesium. Now, that was the next question. Is it a metal or is it a non-metal? It is a metal. Okay? Fluorine. Metal or non-metal? Non-metal. And so if you can do this with every single compound, you would then know the answer to this next question. What type of bond is a metal and a non-metal? Ionic. Well, you've already got 95% of this done. You've identified it. Okay? What about the next one? If you split it right there in the center. Copper. What is that? That's a metal. F is a non. So what type of bond is a metal and a non? Ionic. You've already got that one down. So again, the last one, if you split it, so this is where it's a little bit different. Sulfur. Okay, and the way we know this is what line are we looking at to determine? That stair-step line, right? It's the blue one on that one, and it's the big orange one over there. What side of that stair-step line is the S on? The right side, which tells me that sulfur is a non-metal, and we already know that fluorine's non. So what type of bond is a non and a non? Covalent, fantastic. Now, you've already done an entire sheet on all the covalent bonds. What do all covalent bonds have in them? Prefixes. So if we know that, if we come back over here and look at the compounds, what do you notice about the one that was identified as covalent? It's got a prefix. Okay? So you can identify that as covalent. You've already worked on all those. But look at the other two. Do either of the other two compounds' names have prefixes in them? No, so that automatically tells you it's ionic. Now, one other differentiating factor about ionic is this thing right here. What is that? Roman numerals. I need you to make this note, and you can put it anywhere in here, and it's very important. Okay? Transition. Oh, man, I cheated myself. Sorry. Let's go back to let's look at this. These two right here. We've already labeled them as metals, and you already know the answer to this question. But magnesium and copper are two different kind of metals. What kind of metal is copper? It's a transition metal. And so I kind of cheated my answer on that one. So here's what we're going to do. We need to come back over here and write this. That transition metals, and I promise you this will make sense when we look at ionic. Transition metals need Roman numerals. Okay, transition metals need Roman numerals. Lauren, are you writing this down? If you're not, you should be. Now, I have a question. Why do transition metals need Roman numerals and other metals not? Romy. Perfect. That is the perfect answer. Remember on the bottom box of the polyatomic quiz that you guys had to do, there was a list of all these different things? All right, so here's the situation. If we're talking about copper, how many possible charges can copper have? 2. Lead can have 2. Iron can have 2. Does anybody remember the one that could have 3? Manganese, Mn, right? So does anybody remember what they were? 2, 4, and 7. Very good. So here's the deal. When we're talking about these different metals, you can have copper 1 or copper 2. And so what do you think the purpose of the Roman numeral is used for? Identify which one you're specifically referring to. And when we start doing the ionic ones, it will be very obvious very quickly of which one you need to do, because it's going to make a huge difference in how the formula looks. A huge difference. And so that is why that transition metals need Roman numerals. Okay? So that's the first set. So let's go down to the next set. What do all three of the bottom ones have in common? They all have bromine in common, so Br, Br, and Br. Okay? Now, what do they not have in common? All the first elements are different. So let me ask you this question. If you split Na and Br, what is Na? It's a metal, right? So if you have a metal and a non-metal, what type of bond is it? That's exactly what it says. It says ionic. That checks off. What is Au? It's gold. Now, is gold a transition metal? Yes. Now, all transition metals need what? Does it have a Roman numeral in its name? Yep, it checks off. Okay? And then finally, we've got IBr. Now, what is I by name? Iodine. Is iodine a metal or a non-metal? Non-metal. So we've got a non-metal and a non-metal. Even if I didn't tell you it was covalent, how could you look at the name and know that it was covalent? It's got prefixes. You're already starting to figure this stuff out. So are you seeing the major differences already? So anytime you have ionic, do not have a prefix. Now, remember those Velcro things I told you all the time? Here's a Velcro for ionic bonds. Does anyone know of a time that an ionic bond could potentially have a prefix? Perfect, if it has a polyatomic. Okay, and we're going to get to those. So keep that in mind as we go through that. Now, remember, here's another Velcro. One more second. Hang on 1 second. Right here, I wrote transition metals need Roman numerals. Even in math class, are there exceptions to rules? I'll go ahead and tell you. For this, there are 3. Let me change the color on it. there are 3 exceptions, and we'll see who those are in just a few minutes. Again, this is a Velcro ball, so hold on to that in your brain. There are 3 exceptions. Just 3. Okay? All right, so let's do this so whenever we get to the covalent part, we'll be able to do it. So, names and formulas of ionic compounds, differences. What are some differences in ionic compounds? Very good. No prefixes. No prefixes. Are there any other differences? Very good. What has Roman numerals? Very good. Transition. This pen's so slow today. Transition metals have Roman numerals. Now, on this topic, and I want to completely take a left-hand turn, and I want to spend a second on that word right there. How many of you, if I gave you a quiz, I'm not going to do it, if I gave you a quiz, you could get a 100 if I asked you to do Roman numerals 1 through 10. You could get every single one of them right. How many of you couldn't get 4 or 5 of them right? All right, let's take just a second to make sure that we're all on the same page. That way we know all of our Roman numerals. All right, so what is the Roman numeral for 1? A line. Now, guys, I want to make this very clear. Some of these worksheets you're going to see doesn't have them. For me, just to do it, put a line on it, because I don't know what, like if you mean like a 1 or an L or an I, like put a bars on top of them. Okay? Now, what is Roman numeral 2? 2 lines. 3. Now, this is where some of you, I think, would mess up. I'm going to skip this for just a second. We've got 1, 2, 3. What is 5? V. Very good. So if you noticed, I skipped 4. Whenever you're doing tally marks, well, it's just 1, 2, 3, 4. But what do you do for 4 in Roman numerals? IV. So this is one of the weird ones. So this is where it gets a little strange. Okay, so this is going to be 5. Now, I'm going to go ahead and do something else, and I'm going to skip down, and I'm going to go ahead and go to 10. What is 10? X. Fantastic. Okay, so we've got X. Now, the same protocol applies here. What is 9? IX. So we've got 1 through 5, and we've got 9 and 10. 6 through 8 is where it kind of gets a little bit weird if you don't know what you're necessarily doing. But hopefully you do know what you're doing. So what is 6? VI, 7, VII, and 8. Okay. Lily, is that better? Lauren, better? So if I give you a quiz on this tomorrow, you'll know. I mean, that's 10 free points if you ask me. Now, if I ask a bonus question like, what is the Roman numeral for 50? It's a bonus, maybe. All right. Now, I'm not telling you a bonus. That's not fair. Those are only for transition metals. I didn't say that. Now, real quick. So, what is the names or formula for covalent? What do we notice about these? Well, that we can say that, okay? It's non to non. When do you have prefixes? Okay, there will be a prefix. There will be prefixes. Now, real quick, and I'm just kind of go back to this real quick, just so you know for future instances, when do you use Roman numerals with what thing specifically? Transition metals. Let me go ahead and forewarn you, you will never have a Roman numeral above 7. For future reference, you'll never have a Roman numeral above 7. So when we start doing these, if you get something that's 8 or 9 or 10, you've done something wrong. You'll never go above 7. Okay? Massimo? Okay? Now, were there some similarities in them? What was the similarity, the major similarity? Very good, thank you. Okay, so it ends N IDE. So make sure you have that. All right, everybody okay with this? All right, so I think question 20 is a really good question. It's a lot of you I kind of discussed this with in your groups. Use complete sentences, we don't have to do that, to explain why AlCl3 is called aluminum chloride, and then it tells you no prefix is required, but BCl3 is called boron trichloride. Now I want to show you something real quick. In reference to the periodic table, where are boron and aluminum to each other? They're on top and bottom of each other, right? But why does aluminum not need prefixes? Notice how they are compared to that blue line. One is on the right side, one is on the left side. So, and we already know this. What is aluminum? What type of element is it? It's a metal. And chlorine is a non-metal. So let me actually scroll this up so we can actually write this down. Okay. So we know that aluminum, again, this is a metal. Chlorine is a non-metal. So what type of bond is that? So this is going to be ionic. And what do we know about ionic bonds? There are no prefixes. And so that's exactly why we can answer that. There are no prefixes required. However, boron trichloride, what do we know about boron? It's a non-metal. Trichloride is also a non-metal. So what does that mean? That means it's covalent. Okay? And what do we know about covalent bonds? Okay, so we've got to have some prefixes in there. So prefixes needed. Prefixes are needed. Got that, boys? Got that? Okay, just making sure. All right, so the last thing of the day, for this sheet, my bad, sorry, I didn't mean to say that out loud, is this part. So in the table below, first identify the type of bonding present in each compound. And again, that's what we're going to do. If you will do this every single compound, you'll never get one wrong, because I promise it's going to make it the easiest thing possible to identify. We're going to do it together. Yeah, I know y'all, and I didn't want y'all to waste time on it because I knew it would throw some of you off, so we're actually going to do it together as a group. So if you drew all over it, just erase all that. So here's what I want to do. I want to split all of these compounds in half. So CS is C, a metal or a non-metal? Non. S, metal or non-metal? Non-metal. So as soon as you know that, what type of bond is it? It's covalent. Fantastic. So what are you going to have in your names? Prefixes. Okay. So let me start asking questions. Ashwini, lead, is it a metal or a non-metal? It's a metal. Iodine, metal or non-metal? It's a non-metal. So when you have a metal and a non-metal, what type of bond is that? Ionic. Very good. Baker, barium, metal or non-metal? It's in group 2. Okay. What about chlorine? Okay, so if it's a metal and a non-metal, what type is it? Okay. Ron Howard, selenium. Non-metal. What about sulfur? Non-metal. So what type of bond is that? Covalent, sorry. Okay, I didn't hear you. All right, Emma, so now we're going to go to the other side. We're going to look at the names. Is there anything that jumps off that page that automatically tells you what type it is? Yeah, so as soon as you see tetra, what does that tell you? Very good, it's covalent. Okay. Now, Robin, do you see any prefixes in this next one? No, but let's make sure that we identify it right. Sodium, metal or a non-metal? You tell me, what group is it in? So it's a metal, right? So we have a metal, and phosphorus is a non-metal, right? So this is going to be ionic. And then dinitrogen pentoxide. Maya? How do you know that? Prefix is very simple. Now, Natalie, there's actually 3 things that indicate what the next one is. What's the major one that jumps off the page at you? Has a Roman numeral. And what things have Roman numerals? No, what things? Transition what? Metals. And if you've got that, then you've got ionic. The other 2, one, does it have any prefixes? Nope, so that automatically makes it ionic, and the fact that cobalt is a metal, and it is a transition metal. All right, so now let's actually do some of the compound names. So, Terrell, you've got a compound one, you got a covalent in the first one. Now, so then we've got carbon, we've got sulfur. So carbon. Does carbon need a prefix on it? Why not? Very good, it's just one. So we're just going to write carbon. Now, when does the second one ever need a prefix? Yes, what is the prefix for 2? Di, and sulfur is going to turn into sulfide. So it is carbon disulfide. Very good. Okay, we're going to skip the ionic ones because we don't necessarily know how to do those yet. So, Johnny, let's go with you. So, selenium, does it need a prefix? Why? And the subscript is more than one. So, what is the prefix for 2? Di. Do you change anything about its name? Remember, the ending of the first element stays the same, right? So it's going to be diselenium. Okay. When does the second one need a prefix? Always. Okay. So sulfur needs a prefix, right? What is the prefix for 6? Hexa. So it's going to turn into diselenium hexa what? Sulfide. Very good. Now, let me just say this out loud. To be honest with you guys, some of these don't exist in real life. They just made up some stuff just to get you to practice it. So again, these may or may not exist in real life. All right, Gage. Xenon tetrafluoride. So what you got for the formula? XeF4. Now, how did you know that Xe didn't need a subscript? Very good. And how did you know that fluorine needed a 4? Very good. Guys, let me say this out loud. Please don't be this person. Every year I get this. What is the chemical symbol for fluorine? F. It is not FL. Please do not write FL. I get it every year. All right, Massimo. Dinitrogen pentoxide. Yeah. Try that again. Very good. Now that's okay. Why is it 5 and not 10? Penta means 5. So are you pretty confident in covalent bonding? All right, fantastic. So let's move on to the other one. Let's go over to ionic. So you should have ionic also pulled over in there. So you may need to open that up as well. Ionic compounds. Before we begin, as a matter of fact, okay, when working in chemistry, it's often convenient to write chemical in symbols. For example, we might write down the substance table salt as NaCl. In talking about chemistry, however, it's a bit tacky to say what does that say? Oh, I got it. Okay, that makes sense now. It's the phonetic aspect of it. NaCl. What? That is stupid. Okay, whatever. When referring to a substance. Also, in formal writing, we should use the name of this compound rather than its symbols. Therefore, we need to learn how to say the proper name of its ionic substances. All right, before we go any farther, I need you to add one thing to this entire column. Just one, okay? Under zinc and beside silver, please write this in. CD2+. CD2+. And we'll get to that in just a second, but I want to go ahead and have it in there for you. All right, so let's just jump right into the questions. Question 1A. Identify 3 elements that only form one cation. Just somebody give me a random list. Li? H? Okay, all right. So here's a complete list. And I do want you to add the 2 that I'm writing in purple or pink, whatever color this is. At least write those 2 things. Because do you agree that all group 1s and all group 2s have one state, one charge? Okay. And then I'm also going to include this. Again, if you want to include those three, that's perfectly fine. But all group 1s, group 2s, silver, zinc, cadmium, and aluminum, those are only going to have one charge. All right, identify 3 elements that form only one anion. Where are all those going to come from? Group 17. So, matter of fact, let me actually do this. The easiest way to say it is what side of the stair-step line? To the right side of the stair-step line. So that's another way you can look at it. All right, 1C. Identify 3 elements that form more than one cation. Okay, here's what I want you to write somewhere in this if you didn't write it. Transition metals. So here's what I want you to notice. Inside, what's inside of that green box? All your transition metals. Now, the question that was just asked is identify 3 elements that form more than one cation. Now, are there any elements inside of that box that do not form more than one? Yes. Who are they? Do you agree that those 3 do not form more than one charge? Yes. Do you remember 5 minutes ago, I told you that transition metals have to have what in their name? Roman numerals. But then you also wrote there are how many exceptions? Who are your 3 exceptions? Those 3 right there. Now, why do you think that when we've kind of talked about this, all this is kind of coming back full circle. Why do you think that those 3 don't need Roman numerals? There's only one possible charge. So do you have to identify which one you're talking about? No, it's only one possible charge. Yes, sir. It's 1 and 2, 1 and 2, 1 and 2, 1. Just one option. Not the value, how many of them are there possible? Yes, Mn, 2, 4, and 7. Yes, exactly. More than one possible oxidation state or charge. Does that make more sense? Because if you look, iron's got 2, nickel's got 2, copper's got 2, mercury's got 2, tin and lead all have 2 possible. But silver, cadmium, and zinc. But remember what we talked about, that transition metals have more, they can change. But there are 3 exceptions, and here are your 3 exceptions. Okay, and I'm telling you now, those are the things that you're going to have. That's the only 3 that you have to memorize. Out of this entire periodic table, those are the only 3 you need to memorize. Okay, all right, now let's look at D. In what region of the periodic table are these multiple ion elements usually located? What? Go ahead, Gage. Okay. Again, the same answer as before, transition metals. All right, so let's look at this. And this is where I'm going to start teaching you how to do naming compounds. I've got 15 minutes left, and I guarantee you by 3:10 you'll know how to do it. I promise by 3:10. So question 2. Consider the ions of potassium and sulfur. Write a chemical formula for all possible ionic compounds involving these ions using the simplest ratio, potassium and sulfur. Keep in mind, the sum of the charges in an ionic compound must equal 0. So do me a favor and circle or highlight that very last statement. And the key word in there, or the key phrase, is this one. They must equal 0. All right, so what I'm going to do is I'm going to come off of this page so I'll have a little bit more room to write. All right. So what it said is use potassium and sulfur. Now, you just told me, what does it have to be equal to? 0. All right, this is where I need your help. If you can scroll back up to that little box where that chart was, as a matter of fact, I can actually do it too, so I can bounce back and forth. What is the charge on potassium? What is it? 1 plus. All right, so let's put that right there. So we got potassium 1 plus. All right, what is the charge on the sulfur ion, which is going to be right there? 2 negative. All right, so here's the deal. I need this entire thing to equal what? 0. Well, I can't take away. The only thing I can do is add. If I've got 1 positive and 2 negatives, how do I make them equal to 0? Add another positive. So if I put a 2 right here, is that going to make them equal to 0? 2 positives plus 2 negatives is equal to what? 0. So what would be my chemical formula for this? Now, I heard someone say it the other way. Why is it K2S and not KS2? Because you had to have 2 potassiums. Does that make sense? Yes, no, maybe? Yes. All right, let's look at the next example. Go back, and matter of fact, help me out because I don't know what it says. I think number 3 says this iron and something. Is it iron and sulfur again? Yes, okay. Well, here's the problem with iron. If we look at our periodic table, does it say which iron? Or does it just say iron? Well, here's the deal. Look at iron right here that I'm circling in green. What's wrong with that question? There's 2 options, so let's look at both of them. So here's what we're going to do. I'm going to split it into 2. I'm going to write iron 2 plus S equals 0. And then I'm going to write iron, hold on. Nope. I'm going to write it a different way. So we've got Fe2 plus S equals 0. I'm going to write it horizontally. And then I've got Fe3 plus S equals 0. Now this time, what is the charge on both of these S's if you look at that chart? Let's come back and look at it. Again, it's the same thing. What is it? Minus 2. So if I've got 2 minus there and 2 minus here. So for the top one, I've got 2 positives and 2 negatives. What does that equal? 0. So what's the formula for that? FES. Does that make sense? Now, here's the deal with the bottom one. How many of you hate lowest common multiple and greatest common factor? Like, you despise that part of it. I'm going to make this real simple. There's something in chemistry that I call the 2-3-6 rule. And here's where that comes from. What is the lowest common multiple of 2 and 3? 6. All right. So, if you see a 3, what does it need to get? It needs to get a 2. If you see a 2, what does it need to get? A 3. Well, that should be an easy question. What is 2 times 3? What is 3 times 2? So we have 6 positives and 6 negatives. So what does that equal? 0. Now here's the hard part. What is the formula for this? Fe2S3. Now, here's the deal. Do you agree that this formula and this formula are very, very, very different? But what's the only thing that changed between the 2 questions? That one and that. The charge on iron changed. Simply by changing it 1 number, does it drastically alter the chemical formula? Yes. So do you have to pay attention to those things? All right. Let me give you an example. And again, you're going to have to add a page, or if you're on the package, you can just write this down. So let me give you an example. I'm going to give you 2 of them, okay? So I've got Li positive plus N3 minus. See if you can do that one. Matter of fact, I forgot to add the equal to 0. And then also, what did I do earlier? Ca2 plus I minus. See if you can do both of those. Yeah, just add it. Yeah, or add a page if you're on the iPad. Just put it right there for me, guys. Just back it up against that yellow thing. Push that 2 for me. Thank you. Alright, Sharon, so let's look at the first one. I've got 1 Li plus, and I've got 1 N3 minus. Are those equal as they're written? No, how do I make them equal? Add what? Add 2 what? If I've got 1 positive and 3 negatives, I need to make them equal to 0. I can't take away anything. I can only add. Add 2 lithiums, all right? Now, what's my total value here? That's 2 positives, right? What do I have over here? 3. That's still not equal to 0. So this didn't work. So what do I need to do? Change that to a what? Well, that's 4 positives and 3 negatives. Is that 3 positive? Yes. Is that 3 negative? What is 3 positives plus 3 negatives? 0. Is that what I wanted? Yes. So what would the formula for this be then? How many of you got that? Very good. Okay. All right, Alan. So for this one, what do I need to do to make it equal 0? Very good. So if I put a 2 there, so I have 2 positives, and now how many negatives do I have? Everybody? 2 negatives. So what's your formula? CaI2. Why is it 2I or I2? Okay. All right. 2 more examples, and we're done. 2 more. So here's the deal. This time, I want you to do PB 2 plus F minus equals 0. And then PB, check. See if you can figure that one out. Yep, one of them is lead 2 with oxygen, and the other one is lead 4 with oxygen. Lauren, you get the easy one. Lead 2 plus and lead 2 minus. What happens to your pluses and your minuses? They cancel out. So what would your formula be? How many PBs do you need? Just one. How many O's do you need? So PbO. That's your formula. Okay? All right, Marquise. I've got PB4 plus and O2 minus. What do I need? Add 2 oxygen. So what would your formula be? PbO2. Does that make sense? All right. Now, how many of you don't like the math? I'm going to make it even easier for you. Now, some of you may have caught on to this, but watch what happens. This is called the crisscross method. Works for everything. So if you do it in your head, I had 1 positive, right? How many more silvers would I need to make phosphorus turn into 0? How many did I give it? 3. So this is what you can start doing. This is called the crisscross method. But I wanted you to see where it came from. So you can take any ionic compound and do what with its charges? And crisscross them. But let me show you where Miss Folds would get you if you do this. And I'm just going to show you. All right, so what if we have the charges? Now, if we do the crisscross method, so if we drop the 4 here and the 2 here, what would you write? You would write SN what? 2, O what? If you left that in a math class, would you get credit for it? No. Why not? It's not simplified. So what is the final simplified answer? So there's only one little thing that you got to pay attention to. When you crisscross, what do you have to make sure you do? Simplify if you can. One last one, you can do it in your brain. You don't even have to write it down. See if you can figure it out. Let me find one that I can do that'll work. All right, don't say anything out loud. Don't say anything out loud. Anijah, what is it? Very good. So I was 2 minutes off. It's 3:12, and you can do ionic compounds. Took me 12 minutes to teach it to you. So you can do any of these, I promise.